Okay, volumes of known cross sections. I think you have a pretty good idea of what we're doing now, since you see your shapes, right? But we need to formalize it. Many of you have calculated approximate answers. We're going to work on the integral of that, so it's an exact volume. Okay. So what do we got for the square area here? Okay. What about the semicircle?
1/2 pi.
Make sure it's b over 2. Because it's pi r squared. Radius is half of b. Right? Make sure you're right there. Okay, rectangle. What about the isosceles right triangle?
1/2.
That's interesting. You think I did that on purpose. What about this one? We're not going to run into very much at all.
1/2 b over pi over the square root.
Okay, this is
2 squared.
b over root 2, correct?
Yeah.
Right, so it's 1/2 b over root 2 squared. The nice thing about a lot of these is that you can simplify them and they make really nice integrals in the end. So, for example, this one here. Pi times b squared over 8. Okay, you have a constant, and all you're integrating is b squared. Okay, so it makes it really easy. How about this one? It's b squared over 4. So, any questions on those? You build your shapes. It looks to me like you got the area formulas pretty well. So let's talk about some of you who had the squares. Okay, what did you get for your approximate volume? What was it?
2.
So theirs was a Riemann sum of squares, just like we do with rectangles and trapezoids. How would I calculate this volume with an integral? How tall? Okay, so the questions are going to be asked in a specific manner. Okay? Region B is the area bounded by the x-axis of this region. And here's the x-axis. X equals 9. And the function square root of x. So that's this whole region in here. The bases of cross sections are perpendicular to the x-axis, which I already drew in there, correct? So that's kind of the information phase of these problems. You got to decipher what the region is, and if they're perpendicular to the x or the y. What is the volume of that shape would be the question. Okay, or what is the volume of the figure? Okay, so our integral goes, first of all, it's perpendicular to the x. So that means we're integrating with respect to x. It's going to be dx. Perpendicular. It says perpendicular to y, you have to integrate with respect to y. What are my x boundaries?
0
to 9. Okay. Now, this is where you plug the area formula in to a square. Okay, how big is this base? of this square? How tall is it? Square root of x, for any of them, right? The b is square root of x. And that means the height is root x. So what is the area?
X.
This is the area of the shape. That's what you plug in there. Yep. Integrate the area of the shape from 0 to 9. Have yourself your volume.
So the B is equal to the function.
Yeah, the function height is your base. That's why we did all those area formulas up here. So it was kind of in your brains. So what is the answer to that integral? No.
No.
Okay. No. It's 9 squared. 81 divided by 2. You can see their estimate was pretty darn close. Right? The estimate was pretty close. You want to write it? Just to make it obvious. What about, I'm going to do semicircles with you. I'm going to let you do the others yourself. What about the semicircles? Same deal, perpendicular to the x. So we know that's going to be same setup. What is the area of this semicircle?
1/2 pi u.
Correct. Something like that. What is the radius? B over 2. But what is B in this case? It's the root of x. Right? So we have 1/2 pi times B over 2 squared. And you have to plug that in for B. So that is the area with square root of x as your base. Now, we can simplify that greatly. What's the square root of x squared? X. And the pi is going to ride along, and then we have 2 squared is 4, times 2 is 8. Another pretty easy integral to calculate, right? Who's confused? Anybody else? Look at your semicircle. How tall is it here? Right, but that's because it's the square root of 1. This is the square root function. How tall is it here? Square root of 2. So the function is the root of x. That's how long the base is. The base is square root x long. Right? So we're going to plug that root x into the area formula. The area formula goes in our integral. Anybody get an answer for this?
Yeah.
Yeah. Oh, sure. I didn't think that would be an issue, but if you want to, we can. Okay. It's the constant attached to X, do I need to worry about it? No, I don't. So you can do this. You can pull it out. So the only thing we're worried about here is the X. It's X squared over 2. From 0 to 9. So we get 81 pi over 16. And then the 0 we don't worry about because you plug it in and it's 0, right? So whatever number that is.
Could we stop there?
That's fine. No, we're acceptable. It's the calculator portion of an exam. It might be in decimals. Does that help?
Yeah.
What?
Well, sure, on the back of that picture.
2 times 8.
That means.
81 pi over 16. Okay. Bueno?
Yeah.
I think so. Okay, well, you'll get your chance to prove that. I'm gonna have you do these on your own later. You wanna try one of them right now?
Yeah.
I think we have time, so pick one.
But I saw some string.
Okay, this one, everybody right now, calculate.
It's gonna be the same no matter what.
Isosceles right triangle, go ahead and calculate that one out.
They're the same area.
Is it?
Same area.
Prove it. Write your work out and prove it.
All right.
No, actually, I do. Well, we need to build your interest. Sure. For X over 4. Or maybe it doesn't. So, what numbers did I go right? So, and then it's going to be X, right? So we need to find this right here. So we need to
You
find
waiting help?
the area equation for that. So how we find the area. Can we? So here it is. But we don't want to put it there. That's way too unspecific. And it's not gonna work with our X. So we're gonna put an X in there.
Yeah. That's
Because our equation is right, because we're with X, that is what that value is gonna be. So just plug square root of X or whatever it is in for simplify and put that right there. And then solve.
square.
Yeah, but. So what, the square root of X gives you to the bottom, is it just
The area of the triangle is at least inside.
Yeah.
Yes. Hatcher, what's your answer? What'd you get, Matt? Does anybody disagree?
so
Good.
add 1 to
That's not our pen. I think you are correct. So we do integral 0 to 9. I think 20.25 works.
Our estimation of like.
22, yeah.
Yeah.
The estimates, why are the estimates that I had you calculate overestimates? Think
It's
about
'cause they were
this, look at
months
your
on.
figures,
Because.
why are they overestimates?
Left hand.
It says that it goes all the way over when it slopes down, you know, the tree top, just like that. Yeah.
It's right here, grandma's
Like,
son.
so like the graph slopes down, but the way we did it, we said it's the same top. Oh, yeah.
Oh,
Graph
okay.
is just-
Yeah, it's a, so we'll go over this week, and actually the study session is one of the sessions I'm instructing. Is that function increasing or decreasing? It's increasing. Is it a right or a left hand sum? We started on the right. We started with the big shape, correct?
Yeah.
It's a right hand sum. Okay, if F is increasing, the right hand sum is an overestimate.
Oh,
That is one of the justifications you're probably gonna have to come up with in your head. So you have, that was your original, the right hand, right? If the function is increasing, right-handed sums are an overestimate. If the function is decreasing, right-handed sums are an underestimate. And you could apply the same reasoning to decreasing left-handed functions and increasing right-handed functions.
so are those the same, they will be the same answers?
These?
Yeah.
No, this will have a different answer. That's gonna be yours for you later.
Oh, great. Tell me why though? Why would they be different if it's the same?
The same formula?
Yeah, yeah.
Yeah, probably.
Oh, okay, thank you.
If the area formula is the same, obviously it's gonna work, right?
Yeah.
All right, that's where you're gonna have to pay attention. Region A is the area bounded by y equals 9 and y equals x squared.
So B equals.
The bases of cross sections are perpendicular to the y axis.
And now.
So
Okay, now.
now we're dy,
Is it
correct?
still to 9?
What are our y boundaries? 0 to 9. Okay. Now we need to put everything in here in terms of y. So we need an area. In terms of y. So that means we need to take this function and solve it for x.
For Y. Close enough.
Oh.
Yes. Remember, when you take the square root of a square, you have a positive or a negative that can come. Right? Just think about what's negative 2 squared? 4, and 2 squared is, they can both output. Okay. The question is, how do I deal with that?
Do
Okay,
two
'cause
separate
this
equations and add them.
Here
Two separate.
is the root x, y, and this here is the negative root y. So how tall is the base of my square? Okay, this is root y.
Why? Oh. So it'd be just Y. No.
2 root y's. Right? So,
So the sign is
the
really.
reason these are kind of funky is because you have 2 different non-functions, okay?
Yeah.
So, you can do it 2 ways. One, you can think of it as a root y plus a root y. Okay, so we would be 2 root y's, correct? Or, remember when we did area 6.1, we did area of these shapes, it would be right minus left,
Oh, and it's a negative, so thank you.
right minus left. Y minus negative y. How many y's is that? So it's thinking graphically or thinking algebraically. Right. Okay, so put your mindset in here that it's always right minus left, and you should be good. Okay, this is the positive part of the function, correct? Do you agree?
Yeah.
Okay, that's only starts right here. It doesn't include this side. So from here up, it's the square root of y. But we know this is symmetric, so it's moved y this direction as well. There are two of them. For those of you that are following, what's the area of that shape then? 4 y. Root y times root y is y. It's the meaning of life, it's y. Just accept it as it is. And see how, so the hard part is generating this integral. The integrals are not difficult. The hard part is generating them.
I'm trying to figure out when you.
Yeah. That's it.
Why is it right side of
Remember top minus bottom? The top is positive x, the bottom is the smaller x's. Well, this is the positive y's. Right? The positives go this direction, the smaller ones go this way. So right this. On this one you have to, because you're actually dealing with two equations. Right? Okay. Good. I think I'm comfortable where you're at there. Okay. Aaron, one more. You're gonna, so we've been working in these other examples. You only had one function, right? And the bottom was the x-axis. Well, what if I put two functions together and make my shape? No, you don't cry. You man up and you do it. So we got about 10 minutes here. Let's focus here and get done. Region R in the first quadrant is bounded by the graphs of y equals sine x and x minus x squared. That will be this region here, in between. The solid is formed having circular cross sections perpendicular to the x-axis. Thanks for that. So we're here, right? With diameters in R. This is R. So basically what you're looking at, if you look at this three-dimensional shape, here's the two curves, you're placing circles between them. Now, so what's circle area? They're all, oh, okay. Okay, this is what it would be, I've been showing you, the two-dimensional. This is a three-dimensional graph of it. This is a circle. The circles are oriented perpendicular to the x-axis. If you look at a circle on its side, what do you see? A rectangle. That's like a rectangle. Okay, you're freaking out. Stop. Stop freaking out.
Can you use your little area demonstrator curve thing to show us this?
Area demonstrator curve thingy.
The geometer's notepad.
The little picture thingy.
The geometer's notepad.
I don't think I have a picture of this.
Oh, dang it.
You
That
should
would
get
be
one.
really helpful.
So, you see how that would be curved over the top? And on the bottom, it would have similar curves. So it's basically a circle. Yeah, it's a circle. It's a circular croissant. It's really easy to get mixed up with these if you're looking at the picture wrong. Pay attention to what it says. Perpendicular to the x-axis means dx. Our shapes are circular. What's the area of a circle? Okay, all we need to do is write this in terms of x, right? And we need to find our integral limits. So where do sine pi x and x minus x squared intersect? Can you think this through without a calculator? That is a nasty equation. What does that look like? Okay, so plug 0 in. Does it work? Yes. Sine pi 0 is 0. Okay, so we have 1. Because I thought that might be an intersection. Okay, so true. Okay, now, what is the 0 of this function? Where does it hit the x-axis? 0 and 1. Does that work? Sine at pi, pi times 1 is 0. And 1 minus 1 is about that. You can also use your calculator. This will probably be friendly. Okay. Now, the only other is, what's our area formula? Which one's on top? Because we do top minus bottom, right?
Oh.
Well, if x is 1/2, what do you get?
You get pain and miseries.
You get miserable. Thanks for that.
No pain and misery.
So this is 1/4. What's sine at pi over 2? It's 1.
It's pi.
So this is the top. Right? So our circle diameter is top minus bottom. That is sine pi x minus, right? So what is our circle radius to plug in here?
1/2 by equation.
Divide by 2.
Wait, so
And then that one's this equation.
Right? diameter of the circle is the top minus the bottom, correct? Because the circle is placed in here. Top minus bottom is diameter, but we need radius for the area formula. So we divide by 2. Okay. So what is our area formula? Pi and then r squared. Do we want to calculate that interval?
Maybe on a calculator.
This would be a friendly problem. But it's the same process every time. Put the area, so you gotta find your integral limits. Put the area in terms of the function. So if it's a no calculator problem here, they're gonna say, set up, do not calculate the integral. So this is all you're gonna have to write out. If it's calculator friendly, they will say, set up the integral and calculate the answer. You'll just throw this, your math 9, put it all in. Bam. Got it. Okay. So, any questions on this stuff? We'll practice it. Trust me, we'll practice it. Okay, your assignment for the night is to finish the 2 problems that we did not do in class. Then we will get a lot more practice in, don't worry, but you only have like 15 minutes of work tonight. So you're welcome. Friday. Put your stuff away. If you leave your shapes on the back table, or you can leave them on your desk, it doesn't matter.
Oh, that's why I forgot to wear it.